So coordinate bond is formed by the donation of lone pairs of electrons by these ions or neutral molecules to the central metal atom. For example, K4FeCN6. The ions or molecules bonded to the central metal atom or ion in a coordination entity are called ligands. So when di or polydentate ligand uses its two or more donor atoms to bind a single metal ion, it is said to be called as chelate ligand. Hello dear students, I am Roja, your chemistry lecturer from Vidhyaashram PU College, the Temple of Excellence, Mysuru. So today we are going to start a new chapter, that is coordination compounds. So in this chapter we are going to study classification of inorganic salts, difference between double salt and complex salt, then terms related to coordination compounds, then coordination sphere and coordination polyhedron, then oxidation number of central atom, and table of common ligands, then nomenclature of coordination compounds. So let's start with classification of inorganic salts. So inorganic salts are classified basically three types, that is simple salts, double salts and coordination compounds. And what are those simple salts, double salts and coordination compounds are? Let us see that simple salts are those which contain one acid radical and one basic radical. For example, zinc sulfate, acid radical is zinc 2 plus and then sulfate is basic radical, that is with a 2 minus. So one acid radical and one basic radical. Double salts are those mixture of two simple salts. For example, carnallite or Morse salt. Morse salt is of ferrous sulfate, then ammonium sulfate with 6 molecules of water. Then carnallite is a mixture of potassium chloride, magnesium chloride and 6 molecules of water. Then coordination compounds, which is also known as complex salt, are the compounds in which the central metal atom is linked to the number of ions or neutral molecules by coordinate bonds. So the bonds are not covalent or ionic, it is coordinate bond. That is by donation of lone pairs of electrons by these ions or neutral molecules to the central metal atom. So coordinate bond is formed by the donation of lone pairs of electrons by these ions or neutral molecules to the central metal atom. For example, K4FeCN6. So here iron is a central metal atom where Cn molecules are donating the lone pair of electrons to the iron, and then neutral atom can be a potassium. So this can be an example for the coordinate compounds. So next is, let us see what are the differences between double salt and a complex salt. So double salt is stable only in solid state but dissociate into simple ions completely in solution state. But complex salt is stable both in solid and solution state, that means it is not going to ionize and does not dissociate completely in solution state. Now examples that we have seen before was carnallite and Morse salt, and here for the complex salt it can be FeCN6 4 minus or K4FeCN6. They do not dissociate into ferrous ion and cyanide ions. So that is, let us see definitions of terms related to coordination compounds. Now what are the terms that we come across is mainly central metal atom and ligands, and there is a coordinate bond, coordination sphere, charge of the complex ion, how are they going to be associated. So if cobalt is a central metal atom, we have understood that neutral atoms or molecules or ions can donate the lone pair of electrons to the central metal atom. So here the molecules or ions are going to donate electrons to the central metal atom with forming the coordination bond between all the elements. Now if this whole complex consists of a charge, it is known as charge of the complex ion, and the bond between the ligands and the central metal atom is called coordinate bond, and the molecules that donate the lone pair of electrons are called ligands, and the coordination sphere is because to enclose within the bracket the complex and show what is the charge of the complex ion. and the overall structure is known to be a complex ion, and the counter ions are known to be the one which are called as ions. And then overall the complex ion with the charge is called as coordination compound. So this is how we have to represent. Then next is coordination entity. So coordination entity is nothing but it constitutes a central metal atom or ion bonded to a fixed number of ions or molecules through coordinate covalent bonds. For example, we have seen with the previous example, along with that we have COCl3NH3 thrice, then FeCN6 4 minus is a coordination entity. Next, central metal atom. How do we define the central metal atom is the metal atom or ion in a coordination entity to which a fixed number of ions or molecules, which are called as ligands, are bound in definite geometrical arrangement around is called central metal ion, and it is also called as a Lewis acid. So here are the few examples, that is NiCl2H2O4. Here in this complex Ni2 plus is a central metal atom, and in the complex FeCN6 whole to the power 3 minus, here Fe3 plus is a central metal ion. Next is ligands. The ions or molecules bonded to the central metal atom or ion in a coordination entity are called ligands. Ligands are Lewis bases. So in the example NiCN42 minus, here cyanide ion is known to be a Lewis base or can be called as ligand. So next is what are the types of ligands? There is unidentate ligand. It is a ligand which has one donor atom, or the ligand bound to a central metal ion through a single donor atom. For example, H2O, NH3, etc. comes under unidentate ligand. So unidentate neutral ligands are one. The examples like H2O, NH3, they are complete molecules but carrying lone pair of electrons. Unidentate negative ion ligands are those which carries negative charges, for example OH minus, F minus, Cl minus and etc. Now unidentate positive ion ligands are those which carries plus charge, say for example NO plus, NO2 plus and so on. So next type of ligand is bidentate or didentate, which means two. So this ligand consists of two donor atoms, for example oxalato, which is having a short name OX. Here there are two molecules of ions, like they are going to contribute to the central metal atom. So in the second one is called as ethylene diamine and the short form is EN. And the next type is polydentate. So when several donor atoms are present in a single ligand, the ligand is said to be polydentate. Ethylene diamine tetraacetate ion, that is EDTA 4 minus, is an important hexadentate ligand. So it is polydentate. So it can bind through 2 nitrogen and 4 oxygen atoms to a central metal atom. So this is the central metal atom. Here there are 2 nitrogen and so 4 oxygen atoms that are bounded to central metal atom, forming a polydentate ligand. So next is ambidentate ligand. So ligand which can ligate through 2 different atoms is called as ambidentate ligand. Examples of such ligands are NO2 minus and SCN minus ions. NO2 minus ion can coordinate either through nitrogen or through oxygen to a central metal atom. So from NO2 minus, either N or oxygen can bind to the central metal atom. So similarly, SCN minus ion can coordinate through sulfur or nitrogen. Such type of ligands which donate electrons are called ambidentate ligands. And here you can see either nitrogen or oxygen can contribute to central metal atom. So here is another type of ligand, that is chelate. So when di or polydentate ligand uses its 2 or more donor atoms to bind a single metal ion, it is said to be called as chelate ligand. And example here is taken as EDTA again. So here nitrogen and then oxygen, 4 atoms of oxygen are being taken. Either we can consider nitrogen or oxygen like ambidentate ligands. So such type of ligands are called as chelate ligands. Next is how to find out the coordination number of the coordination complex. So the coordination number of central metal atom or ion is the number of ligand donor atoms to which the metal atom is directly bonded. So that is how we have to count. So how many atoms, ligand donor atoms are being donated to or bonded to the central metal atom. In case of monodentate ligands, coordination number will be equal to number of ligands. That will be very easy. But then for polydentate, we'll have to work on the complex. So here are few examples, like coordination number having 2 is consisting of a geometry called linear, and the examples that includes are AgNH3 twice plus and then AuCl2 minus. Now the coordination number that consists of 4 will have a geometry that is square planar, and examples includes PdNH3 whole to the power 2 plus and then PtCl4 whole to the power 2 minus. Now the coordination number 4 will also have a geometry called tetrahedral. Example are ZnNH3 4 whole to the power charge is 2 plus and CuCl4 2 minus. So the coordination number having 6 will have a geometry octahedral. So the complex includes CONH3 6 3 plus and then FeCl6 3 minus. So here are the few examples. So next topic is about coordination sphere. The central ion and the ligands attached to it are enclosed in square bracket, which is known as coordination sphere. The ionizable group written outside the bracket is known as counter ions. For example, in the complex K4FeCN6, the coordination sphere is FeCN6 and to the power the charge is given 4 minus and the counter ion here is K plus. So the outside the bracket whatever it is written, so it is actually a counter ion. The complexes that are written within the brackets are known as coordination sphere. Next, denticity. So denticity is defined as the number of coordinating atoms present per ligand. So the spatial arrangement of the ligands which are directly attached to the central atom or ion is called coordination polyhedron around the central metal ion. Here are few examples. The ligands which are attached to the central metal atom will make the atom have a structure like different structures, say for example octahedral, tetrahedral, square planar, trigonal, bipyramidal and square pyramidal. So next is oxidation number of central atom. So the oxidation number of the central atom in a complex is defined as the charge it would carry if all the ligands are removed along with the electron pairs that are shared with the central atom. For example, oxidation number of copper in the complex CuCN4 3 minus is +1 and it is written as Cu1. In the complex CONH3 4H2O Cl2 plus and then CONH3 4Cl2SO4. Here in this example, cobalt carries +2 oxidation number. So we have different types of complexes like homoleptic and heteroleptic. So homoleptic complexes in which a metal is bound to only one kind of donor groups are called homoleptic complexes. For example, CuNH3 6 3 plus. So here a metal atom is only bounded to a same donor, and in the heteroleptic it will be of different donors. Say for example CuNH3 4 Cl2 plus. So here we have NH3 also, chlorine also, they are two different ligands. So here we have types of common ligands. So these are given here are like formula name in complexes. Name in complexes is because while writing the nomenclature of the complex we have to use these kind of names. So for coordination compounds it is quite different names that we use in. So let us see based on the types of ligands what are the names that we can give. So for unidentate neutral ligand, so it will have a charge 0 and the formulas that can be used based on the compounds or the ligands are, say for example NH3 name can be used as amine, H2O aqua, CO is carbonyl, NO nitrosyl, PYR is pyridine. It is a name for the pyridine. So next one is monodentate with -1, that is N3 minus is acido, then Br minus is bromido, then Cl minus is chlorido, Cn minus is cyanido, then F minus is fluorido, OH minus is hydroxido, ONO minus is nitrito O, NO2 minus is nitrito N. Then on continuing the same, NO3 is nitrato, then CH3COO minus is acetato, then SCN is thiocyanato, NCS is isothiocyanato, and then with plus charge, that is monodentate ligand with +1 charges, NO plus is given a name nitrosonium, then NO2 plus nitronium, NH2 NH3 plus is hydrazinium, then this is about the monodentate. Next we have bidentate ligand. So the charge here is for 0. 0 with bidentate is BIPY and the name is bipyridine. En for ethane 1,2 diamine, and the charge having -2 will have these complex names, that is CO3 2 minus, then the name is carbonato, O2 minus is oxido, C2O4 2 minus is oxalato, then SO4 2 minus is sulfato. So let's just see nomenclature of coordination compounds, that means how to write the names for the given coordination complex. So naming of coordination compounds and the rules to be followed are as such. So the cation is named first in both positively and negatively charged coordination sites. So the ligands are named in alphabetical order before the name of the central atom. Now names of the anionic ligands ending with O and those of neutral and cation ligands are the same. So exceptions are like aqua, amine, carbonyl, nitrosyl. So that we have to leave it out. To indicate the number of individual ligands, the prefixes mono, di, tri, etc. are used. If these prefixes are present in the names of ligands, then the terms bis, tris, tetrakis, etc. are used. For example, NiCl2PPH3 twice is named as dichloro bis triphenyl phosphine nickel 2. Oxidation state of the metal is indicated by a Roman numeral in parenthesis, that is nickel 2 is mentioned in a parenthesis. If the complex ion is cation, then the metal is named as the element. For example, Fe in a complex cation is called iron and Pt is called as platinum. So we have to use the name of the actual element. Then if the complex ions is anion, then the metal is named with suffix ate ending to the name. For example, CO in a complex anion, that is COSCN4 to the power 2 minus, is called cobalt 8. So Ate is to be added. For some metals, the Latin names are used in the complex ions. For example, ferrate for Fe, that depends on the complex. The neutral complex molecule is named as the complex cation. So here are the few examples with the name mentioned. So let us see. So PTNH3 twice ClNO2 and the name can be given as diamine. It is 2 atoms of amine. Then chlorido, nitrito, N, platinum 2. So the charge or the oxidation number of platinum is given 2. So that is being enclosed within the bracket 2. So K3Cr C2O4 thrice. The name is given potassium trioxalato chromate 3. Next COCl2En twice Cl. So it is called as dichlorido bis ethane 1,2 diamine cobalt 3 chloride. Next CONH3 5 and CO3, then Cl pentaamine carbonato cobalt 3 chloride. Next HgCOSCN4 mercury tetrathiocyanidO cobalt 8 3. NiCO4, it's given as tetracarbonyl nickel 0. Here the oxidation number of nickel is 0. CONH3 thrice H2O thrice Cl3. So tetraamine triaquachromium 3 chloride. Next K2ZnOH4. So the name is given as potassium tetrahydroxozincate 2. So that was about today's session. In the next session, we are going to study about isomerism in coordination compounds. So until then, thank you.